So I guess we're going to get started. Always feel weird when like the speaker is behind you and you can hear yourself when giving a talk. It just with like slight latency. It's like, you know, hot mic when you're like in a podcast or whatever. Always makes me want to like be quiet because I'm talking over someone and then I realize it's just myself. But that's just me. I'm awkward like that. So we're going to talk a bit about WebAssembly, but unlike a lot of other WebAssembly talks, this talk is going to be mostly practical. And there's a very large live demo component that depends on you, the audience, being my load generator. And so what I'm going to ask you to do, which is something that no speaker has ever asked an audience in a talk to do before, is to pull out a laptop or a tablet if you have one. No, it's to pull it out, get it out. Get it out. Because you'll see, you're going to be playing a little game, and it's much better on a computer than it is a phone. Because I don't know how to do web development. I'm one of those weird infrastructure people that they tell you not to worry about. And we'll see that in a little while. I figure, get people prepared ahead of time. Makes it less stressful, you know? So let's talk about some WebAssembly. What is WebAssembly? A portable compilation target, just like assembly, but it's not for a real machine. It's for this imaginary machine, originally intended for a browser. We now run it on servers for a whole bunch of reasons that you can go and watch many other talks about. And then we combine WebAssembly with a thing called Wasm to give you a system interface for doing useful things like talking to a network, opening files, clocks, that pesky thing called time that we all are terrible at dealing with. And basically anything can target Wasm, and language support is constantly improving. At Fermyon, we semi-maintain a thing that tells you a bunch about language support in different languages that we try to keep updated. And if you care about that, that QR code will take you there. Otherwise, Google the WebAssembly language support matrix or something. What makes Wasm great? Wasm binaries are really small compared to the containers that a lot of us are shipping into production. They're a little bit bigger than an x86-64 binary for the same thing, but you don't have to ship your user land with you. And that's really nice. They're fast to start. Sub 1 millisecond startup to shutdown is about the same as executing a useful normal binary, and way faster than unpacking a file system to run a container. And they're portable. You can run the same binary on, Intel, AMD, ARM, RISC-V. I actually have a little Kubernetes cluster that is a Raspberry Pi, a NUC, and then a RISC-V board running in Scaleway. And you can schedule your WebAssembly applications across all of them, and it just works when you do all the work to make Kubernetes run on RISC-V. And they're well isolated. Sandbox execution, linear memory, and capability-based security means a WebAssembly process can only do what you want it to do. You can't just, take over the whole file system by running a random component, which is pretty nice. And, we've come kind of a long way, but now we're getting back to, it's basically bare metal. You just have this little runtime in the way too. And this slide makes no sense since I refactored this. And let's talk a little bit about serverless, and then we'll get on to the demo. What is serverless? Well, the servers are still there. What it is a development model and a type of application. Mostly things that are event-driven and don't rely on sharing state between different executions of the thing. And in this talk, we're going to be talking about Spin, which is a WebAssembly developer tool and runtime that we make at Fermyon. that's currently in the process of being contributed to the CNCF as a sandbox project, which is pretty exciting. And we're also going to talk about SpinKube, which is all of the machinery for doing all of that stuff in Kubernetes with the same performance benefits. So if you open your laptop and go to finicky.terrible.systems, no. You're going to meet our friends, Ninja and Slats. You can be a dog friend, or you can be a cat friend, and you're going to be feeding your friend. So I'm going to give everyone a chance to play. This is much harder to do when you're like standing up front on a stage. I know what things are, totally. And so the interesting thing about our little game here is every time you click a button, it sends a request to a spin application running in Kubernetes, starts a WebAssembly module, executes the code, returns the response, and tears it down. And that is all running in like a Civo K3s cluster in Kubernetes with SpinKube. But let's take a look at that. That's big enough? Big enough for people in the back? Cool. So this is a bunch of different components. We have a tiny little thing for arranging high scores. We have something that generates the game. And that just, at the start of your session, generates everything you need for the session of the game, like pre-generates all of what's going to show up for what you need to feed things. And what you might notice is most of these components are written in different languages. We have a bit of Rust, a bit of Go, a bit of JavaScript, a bit of Python, I think. And they all work together in a single spin application. So a little static file server for the front end, a little thing that redirects you from slash to /index.html, just as an example. A component for tallying scores, and another for generating the session data, an individual game scoreboard, and the high scores. And a bunch of these use, some of these use some shared state. So the scoreboard and the tallier both use a key value store to share state between them. And the high scores are all stored in a SQLite database. And that's expressed using a spinapp CRD, where you can set limits on what you want something to do, and then bind a key value store. In this case, we're using a Redis cache. And we're using a Torso database, like a hosted SQLite replicated thing. They're pretty cool. They run WebAssembly in the database. Like they've extended SQLite with WebAssembly extensions, and so you can do a bunch of really cool stuff by just loading WebAssembly modules via SQL. It's cursed. I love it. I don't know that I would trust that in production, but that's just me. And then we also set up a little bit of auto-scaling and an Ingress. And just, those tokens expire in 25 minutes, so if you want to steal them, be quick. But what's really cool about this is because everything is WebAssembly, and because you're using the WebAssembly system interface to interact with all of those things, we can give you automatic tracing for everything you do in the system. So come on. Honeycomb is great, but the UI is sometimes. So you can see generating sessions. We trigger a Waggy handler, which is basically WebAssembly CGI without any of the ability to talk to the outside world, to just return static data. And then the problem is they're all the slowest. Or when getting the tally to see your current score, you can see that your component is executed. You can see that it went and was backed by Redis for its key value. And you can go and investigate what you were looking up. And that's automatic without needing to add any tracing to your code, which is a pretty neat benefit from doing all of that stuff, because it's also language agnostic. Everything you run kind of just works. Which, that motivates me. I spent a lot of time adding a lot of observability to things. And just the zero setup, it kind of just works. I kind of love it. But yeah. But yeah. And so if you wanted to actually do that yourself, what does that look like? Well, it can be as simple as do all the defaults, please. I can't type on a good day. Go mod tidy, spin up -- build. But what if you want to run that in Kubernetes? You're thinking, oh, this is going to be a bunch of mangling YAML. I've got to go write a Docker file. I've got to get a PhD in YAML engineering. But what if it wasn't that complicated? Here I'm going to rely on Wi-Fi working. Well, I think I have Ethernet here, so maybe it'll work. Push this. Oh. See? Oh, it's not my day. It's one of those days where just everything goes wrong. I had to go back home earlier because I left my laptop in my living room. And when a day starts like that, you know it's going to be something. So we've shoved that in a registry. And then we generate the CRD already. Yes. And then you can see we're running 2 replicas of the new pod. And if we I'm a Kubernetes maintainer, and I typo kubectl things all the time. I can't imagine what it must be like for people who aren't. I'm so sorry. That's not supposed to happen. What's going on? everything becomes an exercise in failure if you rely on the demo gods too much. Oh, maybe? Yeah, what if? I don't know what's going on. I'm humbled by the simplest possible problem. kubectl port forwarding, I always have the worst luck with. Like my dev cluster at home, I run Tailscale inside and just set up like Tailscale ingresses for everything to never have to port forward. That? Really? No? Oh, wait, no. It's because I... No. Oh.
The column between the two ports, right?
You shouldn't need that for... Oh.
Or just type 8080 and use that.
8080 column, 80 column 8080.
Hey! And it can be that simple if you know how a computer works, which evidently I do not today. But really, I want this to be a thing that also, if people have questions about how any of this works, I am very happy to take those today. So yeah, does anybody have any questions?
So do you register a new container runtime, or how is this executed on the node?
So what we have is a containerd shim. A containerd shim basically replaces the runz part of containerd, and we use that to execute WebAssembly directly, as opposed to shipping a full-on container image. We ship an artifact that's just the WebAssembly. In that artifact, we have Wasm time, which is the actual underlying runtime, to isolate all of the requests and all executions. But the shim is what actually backs that. Civo actually pre-install the containerd shim if you use the Talus images. And if you're on K3s, then you can use Kwasm, which will install the shims for you. And in SpinKube, we're working on a new version of Kwasm to handle a bunch of stuff around versioning and make things a lot more robust. Yeah.
Hi. Are there any limitations to what you can do with it compared with our current state-of-the-art Kubernetes running containers?
Always. Everything is trade-offs. Anytime you go for something that tries to build security by default, there's always some stuff that is on the trailing edge of what you can do. Partially through compatibility reasons, you don't have a full libc. You don't have glib. And so there's a bunch of stuff that's just you can't do right now, as stuff gets support for things. There's nothing you can't theoretically do, but on the bleeding edge, sometimes there's a little bit of bleeding, but it's no longer hemorrhaging. It's now just a little bleeding. Doing things like cryptography inside WebAssembly is still really hard, for example, because we don't have constant time operations in WebAssembly yet. And apparently my laptop decided it's nap time. But yeah, there's always things.
Another one. Could you make, let me structure it better. Okay, so you couldn't do the cryptography there, but could you make it to interface to get the data from somewhere else?
Yes. You could. Exactly.
That's it. Thank you.
All right.
Any limitation for using SpinKube on, let's say, Minikube, K3D, or whatever local Kubernetes cluster instead of using K3S in Civo, let's say, or Civo Talos clusters?
K3D is the easiest way to get started. We build a K3D image for you that already has everything in place, so you don't need to worry about shims. SpinKube.dev. In our quick start guide, one of the first things is, here's how you create a K3D cluster that has everything installed for you to go and play with. And it works just about the same. I use Kind personally most of the time, but that just requires also installing the shim yourself.